Scan ban!
No!
di sekretarinya. Good morning, everybody, and welcome to our Series 3 for our fourth APP seminar this 2020 with the theme Advances in Technologies Towards Sustainable Fisheries. For our first part, let us hear the synthesis to be given by Dr. Harold M. Monteclaro, the Vice Chancellor for Research and Extension of UP Visayas.
Thank you, Ma'am Cindy. Magandang umaga po sa ating lahat. My task this morning is to give you a synthesis of our second webinar that was last October 28, 2020. So last week, we invited Dr. Lourdes Cruz to talk about Future Earth Philippines for Sustainability and Resilience. Dr. Lourdes Cruz, or Dr. Luli, as her circle call her, is an academician and a national scientist. She's also a professor emeritus from UP Marine Science Institute, and also a scientist in residence at De La Salle University. In Dr. Cruz's presentation last week, she outlined her presentation into 3 parts now. So at the first part, she talked about the evolution of the Future Earth Initiative. Now, so she narrated how the FEI, the Future Earth Initiative, started to gain ground. But what she emphasized there that when this concept took more than two decades to develop. It started in 1980 when the World Climate Research Program was established. And then in 1986, the International Geobiosphere Program also started. And in 1991, the Diversitas, which is a biodiversity program, was also established. And finally, in 1996, the International Human Dimension Program and Global Environmental Change was also established. And it was only after all of these 4 programs were established that people started to realize that these things are all interrelated and should be integrated into a single system. That's in 2001, as Dr. Cruz presented, the Earth Science Partnership that integrated these 4 programs was established. And then in 2012, at the Rio 20 Earth Summit, the idea about setting up a Future Earth Initiative was discussed. So there were several initiatives as she narrated, and then in 2018, the Future Earth Initiative was finally launched. So this is a global network of scientists, researchers, innovators for a sustainable project, which is supported by 8 organizations like UNESCO, UN University, the World Meteorological Organization, and others. So during her presentation, Dr. Cruz talked about the ecological tipping point concept, and she showed the graph where the x-axis there were drivers there, and then the y-axis there were shows the ecosystem condition. And what Dr. Cruz emphasized was that we should avoid reaching the point that what is called the ecological tipping point when the drivers cause the degradation of our ecosystems, because she said that once the tipping point is reached, it's very difficult to restore the ecosystem. So that was one of her points that she raised during her presentation. And the second part of her presentation, she talked about the sustainable development. So she defined sustainable development as the Brundtland Report defines it as a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So from the concept of sustainable development, there had been discussions on what to do to ensure that future generations will still be able to meet their own needs. So in year 2000, the Millennial Development Goal for 2015 was agreed upon. There were 8 development goals that were targeted, but by 2015, some countries were able to meet the targets or the goals, but others were not able to meet at least all of these goals, including the Philippines. So the United Nations came up with 17 SDGs and 169 targets. Also, in her presentation, Dr. Luli presented that the Philippines has a large ecological footprint. She showed that in 1975 until from 1975, the ecological footprint increased by 3 times. No? By 3 times. So that in 2014, the amount of ecological footprint in the Philippines was about 1.1 global hectares per capita. And she showed that there's a big gap between biocapacity and the ecological footprints. So she emphasized that the Philippines now is actually in a state of ecological deficit. Okay, so we had been running in this mode for the past half century. So meaning we had been running in a non-sustainable mode. So because of this situation, a group of scientists grouped and decided to come up with the Future Earth Philippines. So that's the second part of her presentation. Finally, on the third part of Dr. Cruz's presentation, she talked about Future Earth Philippines. So this program was established to provide scientific and social basis for policies and improve citizen action and stakeholder participation in an effort to attain Philippines of sustainability. And she said that their mission was quite urgent because of, again, that biocapacity deficit that we want to address now. And then what Dr. Cruz narrated is that they wanted to advocate and to work for the participation of all sectors in a national effort to increase the country's biocapacity and also to reduce its ecological footprints as a path towards Philippine sustainability and resilience. So during her presentation, Dr. Cruz emphasized the need for analyzing the problems, coming up with certain process framework for participatory development of knowledge to action programs at the community level. So she emphasized the role of each citizen, not just the national government, but also students and all the residents and citizens in addressing our community, our problems, not just to capitalize on these initiatives and also to engage local government and communities in problem solving and also to enable science and technology at the same time to achieve SDG goals. And then also Dr. Cruz talked about sustainability and resilience. And she mentioned that the Philippines is among the top 10 countries that is affected by natural disasters. So she enumerated several typhoons like Yolanda, Lawin, Ompong, and several earthquakes from in Bohol and Surigao, for example, several volcanic eruptions like those in Mayon and Taal, and of course, recently we had the Yolanda, the Typhoon Rolly that caused much destruction, especially in eastern Luzon. And then she also mentioned about the COVID-19 pandemic and how the pandemic showed the need for the country to improve the resilience of its health system, economic system, and also the educational system. And then during her presentation, Dr. Cruz also presented the status of Philippine sustainability using the SDG report. But her presentation was the status before the COVID pandemic. But she showed that the country had an overall score of 65.5 out of 100, and the Philippines ranked 99 out of 166 countries. So we belong to the 59.6 percentile. There. And then Dr. Cruz also presented the concept of circular bioeconomy of well-being, which is an important concept today. So this is a conceptual framework for achieving sustainable well-being in harmony with nature, and we should. She said that we should operate within ecological boundaries and within boundaries of renewable energy. So Dr. Cruz also, on the topic of SDGs and where the Philippines now is now, so she focused, at least for our concern as fisheries technologists, she focused on the life below water SDG, and under this SDG, there are 5 indicators na, and how are we? And she presented how we're doing based on those indicators na. So she said that in terms of the indicator about the mean area that is already protected, no, areas that are important to biodiversity. Dr. Cruz said that we are stagnating on this target. In terms of ocean health index and clean water scores, um, she said that we are moderately improving, right? But in terms of fish that are caught from overexploited or collapsed stocks, apparently the country is not doing good on this, so we're going down, based from this indicator. In terms of fish caught by trawling, she said that we are on track. And in terms of marine biodiversity threats that are embodied in imports, she said that we're doing good on this, but the information is not available. But overall, she said that there are the minor improvements, especially on the SDG about life below water. She said that the target, our target, is still far from the ideal. So we have to do more to improve, to attain all of these targets. And finally, there. So after that, her presentation, it was followed by an open forum. There were a lot of discussions, primarily on the effect of the pandemic, the COVID-19 pandemic, on the SDG goals, and how the pandemic, for example, which which among the targets, for example, was most affected by the pandemic, and how many years worth of work was affected by this pandemic. So Ma'am Luli shared that in terms of well, there had been reports, anecdotal reports, that in terms of atmospheric pollution, for example, so in this case, the pollution decreased because of the decrease in of automobiles and vehicles that are plying our highways now. So, but she said that health was certainly much affected. Our economic system was also affected, particularly in urban areas, because a lot of people lost their jobs. A lot of business closed down. Drivers could not go. Jeepney drivers were not allowed to operate, and people were less mobile. So people were affected. But she said that the impacts of COVID and the SDG goals need to be really evaluated. But what she said was that this pandemic showed one thing, that we are struggling to cope with the situation. We're not ready. Our economic and social education systems are not ready for in situations like this. Another question was how do we go forward, SDG. So Ma'am Luli shared that as part of their program, the second part of their program, they went to the regions for consultation, and then she said that their team cannot do it alone. So that is why during the second phase of the FEP initiative, the FEP program, they wanted to involve other national agencies now, because in the past they've been working with the OST. This time, they wanted to bring other national agencies like DA, DNR, Climate Change Commission, NEDA, along to work with them towards achieving their goals in the program. Also during the open forum, Ma'am Luli was asked if there were changes because of the pandemic. So she said that it's not just about the, she mentioned economic collapse, issues on health, and many other social aspects brought about by the pandemic. She mentioned that there were a lot of concerns about mental health, no, there. But again, she said that apparently we're not ready with this pandemic now. When asked about the factors that affect the Philippines in achieving SDG goals and which among the goals are most achievable, Ma'am Luli shared that among all the SDGs, now, well, that was before COVID, no, she said that in terms of SDG 1 on poverty, reducing poverty, she said that we were kind of on track already. Na. We already had established our hazard maps. Daming mga, there had been post-recovery programs. Na, but yeah, but because of the pandemic, things started to change now because of the economic, the closure of economic activities. A number of several OFWs came home and then failed to return to their jobs abroad. And then a lot of people got displaced. So she said that this would, of course, affect how we can achieve our SDG goals. There was a question on how the state universities and colleges could join the Future Earth program. And Ma'am Luli said that once they have made arrangements with the national committee, she said that they were planning to go out, and then she said that they have regional agencies now. But yeah, they were planning to reach out with other sectors, not just in the national level, but most especially in the local level. Okay. So yeah, during the discussion, Ma'am Luli emphasized that the need to choose wisely and vote wisely during elections, and the need to ensure that we vote politicians that show real concern about sustainability. There was a question about biodegradable plastics and if they are really safe for the environment. And then Ma'am Luli said that a lot of these plastics are not really biodegradable. And she shared some examples of initiatives to replace plastic, like seaweeds, and then the seaweeds. Ma'am Luli was also asked about her opinion about the Manila Bay White Beach project and how we can change the mindset of the government and how this mindset affects sustainability. So Ma'am Luli shared that they had a policy 2 weeks before the webinar, and they brought along a number of experts to talk about Manila Bay, and she shared it's not really toxic. It's toxic when it's in a dust form, when it's when it's inhaled, but when it's placed in water, the problem about dust is minimized. But she said that the focus should be on cleaning Manila Bay first before adding cosmetics. And she said that it's very expensive, and especially the maintenance of such project is also effective. And she also talked about the impact of such project in Cebu, for example, where the dolomite came from. There was a question about how the SDG and education, the targets, our score decreased now, and whether the K-12 program helped. What was the criteria? The question was, what was the criteria when they declared that our SDG goal education decreased now? Ma'am Luli, well, she said that she hasn't really looked at the indicators now, but she said that the issue about education is related to poverty, because a lot of households had problem with finances. So a lot of children, for example, no longer go to school, but instead they help their household to get livelihood, not to get into, yes, to sustain their life, their household. No? Another question was how we can encourage the youth to attain SDGs. No? Um, and Mom Luli was really happy to share her experience with scholars from the DOST SEI program. So she shared that they had a workshop with high school students, na, and then um, during such workshop they invited people from the barangays, na, from the villages, na, and so there was a chance, na, for students and community members of the community to talk about certain problems. Na. So they did they analyze certain problems, na, and then they came up with several proposals, and then this activity allowed the students to go into the barangays, na, into the communities, and to check, what's really the problem, no. So this and then out of this activity they came up with several proposals, no, and uh, and then they're quite they're looking forward for the approval of such proposal, no? And that these projects, no, these proposed projects would finally be implemented in the community, no? But what she emphasized there is that sustainability has to involve everybody, no? From the top level, from national government down to the community, no? And and during discussion, uh, uh, it was mentioned that it gives a certain sense of ownership, no, among the community members, no? So she said that this is doable. It's a very simple activity, but can uh, create a lot of solutions, no, especially at the community level. Dr. Cruz was asked about reclamation and the coal plants that are found all over the countries, uh, and how these reclamation projects, could displace fisher folks, and then how this will affect the SDGs. Well, on this issue, Ma'am Luli again shared that these problems are really complex. Uh, she mentioned that one of the causes of the problem is really the politicians. Like she narrated again Manila Bay as an example, and she emphasized the need for consultation, and that and behavioral change, not only among the residents but also among our national and local leaders. Another question was, despite many MPAs and closed seasons that were established, why does the Philippines still have low scores, no, on life below water? Uh, um, Dr. Cruz said that the issue really is on the uh, practice now of fishing in overexploited areas. So we're still doing fishing operations even when the stocks are already in their overfished states. She said that trawling had decreased now, but some other indicators were not doing well in that. Um, Related to this question, Ma'am Luli emphasized the need for more technical persons, especially in the government. She narrated that in Thailand, for example, the government hired a lot of extension workers, and these extension workers were sent to several trainings. They were sent to universities, and then when they went back to their local communities, they still work with their local universities. So yes, all of this. Um, she cited such examples. And she also emphasized the need for science and evidence-based policies. There were other questions about the the impact of the COVID, but as Ma'am Luli said, there there's still a need to evaluate such impacts now. Right? How about the environmental laws? She mentioned about solid waste, na how such problem had been there a long time. But again, she emphasized the need for all stakeholders to help together. There was a question about how Dr. Luli's group is working with NEDA, no? And who's really in charge of the SDGs. Yeah, there was a discussion about this. No? Uh, and she was asked how governance could be waived in knowledge to action activities, na programs. Ma'am Luli shared that at the moment, na participation from the local community is still low. Na, again, she emphasized the need for all sectors to be working together. Na. As parting words, Ma'am Luli said that there's a need to address that biocapacity and the ecological footprints, the deficit in terms of biocapacity. We need to do more advocacy regarding development and regarding sustainable development and how to bring about behavioral change. She emphasized the role of students in achieving our sustainable development goal agenda. She emphasized the role of the community as well, and she mentioned citizen science. There's data that can be gathered by ordinary members of the community, like fishermen, for example, and yeah, she emphasized that we need to work together. So the second webinar started at around 9 a.m. and then we ended at 11:08 a.m. So that ends my synthesis of the second webinar. Thank you.
Thank you very much, Sir Haro. We'll now go to the presentation of our third speaker for this morning. May I now call on Mr. Dominic Mediodia.
Good day, everyone. Allow me to introduce our third speaker. Our third speaker took her bachelor's degree in applied physics, her master's degree in physics, and her doctorate degree in physics at the National Institute of Physics, University of the Philippines, Diliman. She is a recipient of the DOST ASTHRDP postdoctoral fellowship and did her postdoctoral fellowship at the NASA Goddard Space Flight Center, USA from May 2010 to December 2011. She was also awarded Best Young Author Award in 2012 during the ISPRS Congress, Melbourne, Australia. ASEAN US Science Prize Women winner in 2018, and the 2019 Outstanding Women in Nation Service. She published peer-reviewed scientific papers in both local and international journals. The recent ones are Determination of Cloud Top Height through Three-Dimensional Cloud Reconstruction using Diwata-1 data, a novel approach for vegetation classification using UAV-based hyperspectral imaging computers and electronics in agriculture, forecasting and monitoring agricultural drought in the Philippines, and International Archives of the Photogrammetry, Remote Sensing, and Spatial Information Sciences. Her research interests include satellite remote sensing of the environment, seasonal and climate change prediction, climate change and variability, complex system, and interdisciplinary applications of physics. Currently, she is an associate professor of the Institute of Environmental Science and Meteorology, University of the Philippines, Diliman. Ladies and gentlemen, our third speaker is Dr. Gay Jane Perez with her presentation, Application of Advanced Technologies in Fisheries.
Good morning. I am delighted to join you today in this virtual conference of the Asosasyon ng mga Profesional sa Pangisdaan ng Pilipinas. I hope you'll gain some insights from my presentation entitled Applications of Satellite Technology in Fisheries. I am Gay Jane Perez, an associate professor from the Institute of Environmental Science and Meteorology, University of the Philippines, Diliman. Diwata-1 was deployed from the International Space Station in April 2016. It is a 50-kilogram satellite equipped with 4 cameras that take images of the Earth's surface at different resolutions. During the same year, the Philippine Earth Data Resource and Observation, or PEDRO Ground Receiving Station, was established at DOST-ASTI. PEDRO is instrumental in the operations of Diwata-1 and in receiving high-resolution data from commercial satellites. 2 years later, Diwata-2 was launched from the Tanegashima Space Center in Japan. Diwata-2 aims to continue the missions of Diwata-1 for environmental monitoring and post-disaster assessment. Just last week, we celebrated the second-year anniversary of Diwata-2 by highlighting its successful coverage of more than 80% of the Philippine land area to date. Last year, the Philippine Space Agency was established. It will be the primary policy, planning, coordinating, implementing, and administrative entity of the executive branch of the government that will plan, develop, and promote the National Space Program in line with the Philippine Space Policy. Despite being new, the Philippine Space Agency is not starting from scratch. It leverages from a number of space science and technology application activities that have been initially pursued as project-based initiatives, contributing significant milestones for the country's space program. This includes the experiences with Diwata-1 and Diwata-2. This year, we started the development of an advanced satellite platform with multispectral imager. Expecting to be launched in 2022, it will generate operational quality data for various applications. These satellites play an important role in monitoring the Earth's land, marine, and atmosphere. As they orbit around the Earth, they remotely measure the physical, chemical, and biological properties of the surface. At its unique vantage point, it can cover a wide area, including remote locations and environmental conditions that are normally very hard to measure directly or on site. It can also collect several data simultaneously. And with a relatively long history of satellite observation, data availability dates back to over 4 decades now. With our ground receiving station, we can even access some of this data at near real time. This is important for applications that are time-sensitive, such as in disaster response and recovery efforts. Satellite data are processed to generate analysis-ready data that technical users can further analyze together with ancillary data and models. This will result to value-added products, information, and services for end users' easy access and basis for planning and decision-making. Currently, we have access to a large collection of satellite data through PEDRO Ground Receiving Station, shown here with satellite icons, and open data access from national space agencies such as NASA, ESA, and JAXA, shown here in green fonts. These satellites either operate in the optical or microwave range of the spectrum. At optical range, the information is derived from the reflected signals. Different surface types reflects visible light at varying degrees, resulting to differences in visual appearance. For example, a turbid water looks brown, and clear ocean water is blue. Satellite sensors can detect this variability with very high precision, translating it to quantitative estimates of surface properties. One of the main limitations of optical satellites is when targets are obscured by clouds. This is where microwave satellites come into play. Microwave signals can pass through clouds and can interact with the surface, giving useful information about the targets despite being covered by clouds. They can also operate at night. Satellite data also have different resolutions for a variety of intended applications. High-resolution data can detect up to half-a-meter-sized objects such as cars, trees, and houses. These are very useful for disaster assessment and object identification. Pedro have subscription access to GeoEye-1, CompSat-3, and WorldView 2 and 3 that provide very high-resolution data for government and research use. Our satellites Diwata-1 and Diwata-2 give moderate resolution data ranging from 3 meter to 125 meters. What it lacks in spatial details is compensated for by the wider aerial extent and more spectral channels, enabling several applications. A constellation of planets Dove satellites can provide almost daily coverage of the entire country. Complementing optical data are moderate to high-resolution SAR data from ComSat-5, Cosmos SkyMed, and Novasar-1, where the Philippines is a mission partner, together with UK, India, and Australia. Open access data from Landsat, Sentinel, VIIRS, and MODIS also provide very useful data for regional analysis. Satellites can measure several water quality parameters, such as chlorophyll A, Sagitt disk depth, color dissolved organic matters, total organic carbon, dissolved organic carbon, total suspended matters, turbidity, sea surface salinity, total phosphorus, orthophosphates, chemical oxygen demand, biochemical oxygen demand, electrical conductivity, and ammonia nitrogen. It can also detect geological features such as shoreline, bathymetry, and sea level height. Benthic habitats including mangrove forests, coral reefs, and seagrass beds, and artificially built structures like fish pond, fish cage, fish pen, and fishing vessels. From ridge to reef to high seas, satellite data can provide actionable information that can aid in the management of our fisheries sector. In the following slides, I will be citing some use cases and applications of satellite data to fishing and aquaculture, coastal and ocean monitoring, control and surveillance, and water quality and coastal management. Early this year, BIFAR Region 8 issued several red tide advisories in Matarinao Bay in eastern Samar. The shellfish toxicity level has gone up beyond regulatory level, making it unsafe for human consumption. Looking at a series of processed satellite images from February to June this year, we can see a relatively large variability in chlorophyll A concentration around the bay. Blue indicates low level of chlorophyll, while red suggests high concentration. Studies show that increased chlorophyll A concentrations are associated with high phytoplankton activity, an indicator that there is high nutrient loading along the coast, which is a common precursor of red tide. The highest chlorophyll A concentration is observed in April, where almost the entire coastline of Matarinao Bay showing up as red. However, for the other months, Some areas appear to be more affected than others. In the future, information like this can be used for a more precise or targeted advisory in order to lower shellfish loss and also lessen the impact to people's livelihood. In May this year, there was a report of fish kill event in Laguna de Bay. Moderate resolution satellite data show algal blooms surrounding Talim Island in the Central Bay shortly after the fish kill event. Using historical in situ data collected by the Laguna Lake Development Authority, spanning from 1999 to 2010, and matching satellite data, water quality models were developed using cascade feed neural network and multiple linear regression. Through data analysis, water quality parameter such as pH level can now be derived from satellite observations. We can see that during the fish kill, which is denoted by the shaded area in the graph, there is an increase in pH values, a likely contributor to the fish kill. Before that, satellite images also show relatively more turbid waters with high total suspended solids, which may lower the dissolved oxygen level in the water column, which triggered the fish kill. Aquaculture research and operations have begun adopting technologies such as artificial intelligence together with satellite data in accounting, mapping, and monitoring nationwide fish ponds and fish pen facilities. DOST-ASTI, through the DATAS project, conducts research in partnership with the Bureau of Fisheries and Aquatic Resources, or BIFAR, of the Department of Agriculture and the Philippine Statistics Authority to assist them in creating a nationwide inventory that can be used to monitor fish pens and fish ponds in highly dense areas all over the country. The figure shows a Novasar image of Bolinao, Pangasinan, taken last April. The locations of fish ponds, fish cages, fish traps, and fish pens were automatically identified in the image. Information like this is important in assessing whether the carrying capacity of the area is already met or exceeded in order to find the appropriate countermeasures to make fishing sustainable and avoid further environmental degradation. Here, we use satellite data to predict where fish schools are likely located. We use environmental indicators derived from satellites, such as ocean temperature and plankton concentrations, to identify and locate productive fishing grounds. You will see in the left figure that for this particular month, the seas surrounding the islands of Sulu and Tawi-Tawi are generally productive. This is confirmed with the nightlight data, also derived from satellites, indicating the location of fishing vessels. Equipped with this tool, our fisher folks and managers alike can optimize their resources, like possibly reducing the time they spend looking for fish, hence giving higher economic returns, to determining when and where closed fishing season must be declared to allow fish stocks to replenish, and even in catching illegal fishing activities. Similar technology can be applied in fish farm site optimization. By relating environmental predictors from satellites with commodity production statistics, models can determine suitable areas for fish farming, as well as management strategies like determining the optimal time for harvest. Now, this is an interesting study that quantified the economic value of fishing in the high seas as reflected by satellite data. Using Global Fishing Watch satellites captured automatic identification system, or AIS data, a GPS-like device that broadcasts the location of large vessels, and machine learning techniques, researchers have analyzed the activities of 3,620 vessels operating in the high seas in near real time. These technologies Advances enable them to quantify high seas fishing efforts, costs, and benefits, and assess whether high seas fishing is economically viable. It appears that fishing in the marine waters beyond national jurisdiction is dominated by a small number of fishing countries, which reap most of the benefits of fishing in internationally shared areas. Only 6 countries, namely China, Taiwan, Japan, Indonesia, Spain, and South Korea, accounted for 77% of the global high seas fishing fleet and 80% of all AIS or VMS-inferred fishing effort. Using vessel-level data on ship length, tonnage, engine power, gear, flag state, trip-level fishing, and transit tracks, speed, and other factors that affect the costs of fishing, the estimated total cost of fishing in the high seas in 2014 ranged between 6.2 billion to 8 billion US dollars. The total fisheries catch from the high seas at that time was 4.4 million metric tons with an aggregate revenue of $7.6 billion. The top 3 countries that accounted for 45% of the global high seas fishing revenue are China, Taiwan, and Japan. However, it is interesting to note that returns of fishing in Northwest Pacific is not always positive for these countries, with Taiwan incurring the same losses despite government subsidies. Surprisingly, Japan shows economic losses in areas closer to its shores unless subsidies are factored in. These findings are intriguing, which led the researchers to speculate that fishing the high seas would only make sense for the most unprofitable fisheries due to a combination of factors, which include underreporting of fish catch, vessels fishing only part of the time in the high seas and make most of the economic benefit from fishing in the EEZs, and economic subsidies not accounting for reduced costs because of unfair wages or forced labor. It also seems ironic that the largest players in high seas fishing are countries surrounding the Philippines, and with us being a non-player despite our strategic location. Aside from strong government support and subsidies, these countries are known to exploit satellite technology similar to what I presented earlier, which equip them with the right tools to fish in productive international waters. Our local fisher folks usually fish within municipal waters and inter-island seas within the EEZs, as shown by this nightlight data. A cluster of bright spots in the open waters are indicative of location of fishing vessels. We find hotspots in West Philippine Sea, Tayabas Bay, Regay Gulf, Bulalaco Bay, Sibuyan Sea, Panay Gulf, and Green Island Bay. During the community quarantine period, a significant decline in fishing activities is observed in April and May in the West Philippine Sea and the seas surrounding the northern islands of Palawan. This could serve as another indicator of the impacts to the livelihood and fish production of the ongoing pandemic. To summarize what I've presented so far, satellite technology have wide applications in fishing and aquaculture, which include mapping of fishing zones, forecasting algal blooms, fish stock numerical modeling, fish farm site optimization. From these applications, we expect the following benefits: increase productivity, limit the waste of contaminated shellfish, facilitates the performance inventory of aquaculture, more efficient and eco-friendly fishing, and support sustainability of fish stocks. These applications are useful to fish farmers and fishermen, public authorities, environmental agencies, and the general public. Let me continue with another set of applications for coastal and marine monitoring, control, and surveillance. Using SAR data, these ships are found to be docked in Mischief Reef, possibly taking refuge in preparation for an approaching typhoon. The ship's location were later validated using high-resolution optical imagery. Given that Mischief Reef, locally known as Panganiban Reef, is one of the contested islands in the West Philippine Sea that underwent significant developments by China, it is very likely that this fleet also belongs to China. This kind of information are vital in securing our territorial waters. Further enhancing our maritime domain awareness is through the use of AIS together with SAR and high-resolution images. An automatic ship detection algorithm will be built into the CIASAT portal to serve as a complementary maritime surveillance and monitoring system of the National Coast Watch. As you can see, the rectangular boxed area in the top image are locations where AIS signals are detected, while enclosed in diamond are location of fishing vessels detected by SAR. These are later confirmed by the high-resolution image below. It is interesting to note that there are several ships that do not transmit AIS signal, while one gave false information. With this information, we can confirm authorized activities near our shores and easily flag suspicious ones. These images have been used to validate reports of sightings of foreign vessels in collaboration with the Philippine Navy Maritime Research Information Center. Here is another example showing Multi-Regional Management Fisheries Organization, or RFMO, interactions as illustrated by the AIS tracks of a Japanese longliner identified through the consolidated list of authorized vessels. The vessel fished in the Federated States of Micronesia's EEZ for 4 months before heading to the port at Auckland, New Zealand. It continued fishing within New Zealand's EEZ for 2 months before returning to the port and then traveling to the high seas west of Australia. There it fished for 2 months before it headed back to Japan, stopping at Bali, Indonesia. It remained in the port of Japan before traveling back to the Indian Ocean to fish in the high seas south of India. Governance of this type of fishing requires very high levels of cooperation between competent authorities and strong monitoring, control, and surveillance. The application of satellite technologies was demonstrated to increase maritime domain awareness. Equipped with this tool, we can detect unauthorized activities such as illegal, unreported, and unregulated fishing. It can also help the optimization of navigational routes. Among its benefits include enhanced conservation and management of biodiversity beyond national jurisdictions, decrease ecological impact, monitor area-based management tools, and avoid loss of goods. The end users include ship owners, public authorities, national agencies, and the general public. The last set of satellite applications that I want to share with you pertain to water quality, monitoring, and coastal management. The maps on the left show SST anomalies on March 2015 this year, and 3 months later. Red colors represent positive anomalies or increase in temperature, while blue denotes negative anomaly or cooling. The SST anomaly was computed using the average record from 1971 to 2000. The map shows warming in Mindoro Strait as early as March, which further expand to the rest of the western seaboard of the country by June. The time series graphs in the middle show that the temperature in Calatagan, Batangas ranges from 26 to 31 degrees Celsius with a positive anomaly very close to 1 degree in May. The situation in Calawit, Palawan is worse, with temperature exceeding the 1 degree anomaly threshold in June. Both municipalities reported coral bleaching incidents around this time. With the lockdown situation, it was more challenging to validate coral bleaching incidents, but with satellite images, we can identify critical areas that are threatened with coral bleaching. It is important to monitor seagrasses, corals, mangroves, and sandy areas because they are home to various marine species. The figure shows a group of islands in Bohol that are under the National Integrated Protected Areas System, or NIPAS. The land cover was classified to determine the extent of benthic habitats. Continuous monitoring of these sites helps us determine if there is a decline in the NIPAS site's benthic habitats and at what rate the habitat is declining or degrading. This can then provide science-based recommendations for stricter protection, conservation, and rehabilitation if necessary. Using Diwata-1 and Sentinel-3 images, we derive the total suspended solids in Laguna de Bay at different times of the year. Satellite images can provide a especially comprehensive assessment of water quality, which is difficult and tedious to do through conventional water quality monitoring approach. Hotspots, or areas with high frequent TSS values, can be easily identified from satellite images. This is crucial in identifying potential pollution sources and areas vulnerable to low dissolved oxygen, which may result to fish kill. Complementary use of Diwata imageries with other optical satellites, such as Sentinel-3 in this case, have increased the temporal frequency of observation of the lake. Pollution emanating from Bacoor Bay and Pasig River. This is depicted in maps by the increasing turbidity levels in these areas between March 18 to 25. And lastly, I would like to touch on one of the controversial topics lately, the dolomite sand in Manila Bay. Using a time-lapse of high-resolution images, we can see the expansion of the white sand beach in a small portion of the bay between August to September this year. Similar technology can be used to monitor reclamation areas and coastal or beach erosion, which are very important for coastal management. Satellite data is a useful resource for managing reef ecosystems, monitoring shorelines, mapping of marine protected areas, and mapping coastal erosion and sedimentation. With its use, we can improve protection of aquatic species and marine biodiversity, shoreline conservation, improve coastal and marine spatial planning, and increase in tourism activities. The end users include environmental agencies, industry, national agencies, international organizations and NGOs, and the general public. I would like to conclude my presentation by sharing with you the value of coastal and marine observation as presented in the Copernicus Market Report. While it's meant to evaluate the contribution of the European satellite system, these impacts are generally true for satellite technology applications. First is economic impacts. With use of satellite data for fishing and aquaculture, it can lead to better management of fish farms and ultimately increased productivity. Ship routing leads to better optimization of routes and less spending on fuel. While coastal management, such as better anticipation of coastal erosion, can increase attractiveness of coastal areas. Overall, this translates to about 51 to 191 million euro gain in 2018. As for the social impacts, improved knowledge within the marine sector, such as improved monitoring of water quality and bacteria spreading, improved awareness of the existence of monitoring techniques to survey coastal areas, and detection and monitoring of the seventh plastic continent or the Pacific garbage patch, results to adapted response to public health issues. Improved monitoring of sargassum and other seagrass species, improved monitoring of coral reefs, improved monitoring of jellyfish blooms can result to increased tourism. For environmental impacts, increased knowledge on water conditions will diminish reliance on fuel thanks to optimized routing, which eventually will reduce greenhouse gas emissions. While the ability to monitor new aspects of the environment, for example, surveillance of fish farms and of coastal waters, will lead to support to development of marine renewable energies and support to sustainable fishing. Finally, strategic impacts such as provision of statistics and trends and fishery policies and tracking if regulations are respected. I would like to thank the Stamina for Space program, particularly the GRASP project, Pedro, Pedros, Pedro Datos, and the Philippine Space Agency for the satellite applications that I presented in this talk. Thank you very much, and I look forward to having an engaging discussion with you.
Thank you very much, Dr. Gay. Dr. Gay is with us this morning, and she will be available to entertain your questions. Dr. Gay, we have one question here. Dr. Gay, you're already with us.
Yes,
Okay.
hello, good morning.
Good morning po. Ito po yung first question. What are the challenges that you have encountered during the conduct of geospatial activities, and what were your strategies?
All right, so there are a few challenges. So one would be, I guess, on the training of or expertise of the people to analyze this data. So there is some initial difficulties with regards to processing of satellite data. For one, these are huge data set. It requires substantial computing power and also the right background to analyze them. So, but with sufficient capacity building and initial investment, say in hardware and software, then this could easily be overcome. The other challenge is on the availability of the satellite data itself. While most of the data are open and available freely for our use, they are generated by space agencies like NASA, ESA, and JAXA. There is also some challenge in downloading them, and we also need high resolution data to validate and to aid in the better interpretation of this moderate resolution data. And that can be quite expensive. But with our Pedro facility, we are able to downstream this cost with having one institution paying for the subscription. And yet the data are made available to other government agencies for research use and operational use, as well as to the academe. So those are the two initial challenges that we encounter in using this technology.
Dr. Gay, ito pa yung susunod. Most of
Opo.
our fishermen from coastal communities cannot afford for these fishing technologies. What are the possible assistance that government can extend for our fishermen? And with the date, you mentioned earlier that you were in partnership with another or one agency. Will this be available to our LGUs for their use?
Yes, opo. Actually, that's one impression, no, the cost that's needed to acquire this technology. And I wouldn't deny the upfront cost for hardware. Well, if we build our own satellite like Diwata 1 and Diwata 2, of course, that's also quite costly. It's quite steep. However, the key is for it to be analyzed by certain agencies. So you're right, we partner with government agencies like the Department of Science and Technology. In Advanced Science Technology Institute, they have Pedro, ground receiving station, and Datos help desk, which process this data. Later on, this will be continued through the Philippine Space Agency. So how can our farm fishermen take advantage of this technology at more affordable cost? So this is where maybe decision support tools that can be developed by our partners in the academe or maybe even in the private industry can be made available. So if it's from government, then it can be free. LGUs can make use of these decision support tools in the form of apps in cell phone, or maybe just even a simple text messaging platform where information can go directly to the fishermen. They don't need to analyze the data themselves, but the satellite data are now converted to decision ready information that they can use.
Okay, Dr. Gay, how useful and how comprehensible are this data for our LGUs?
Okay po.
At a level that they will be, it will be easily understood for them, and then they could easily translate it for their own purposes.
Okay po. In terms of comprehensive coverage, so it's comprehensive in the sense that with satellite technology, we cover the whole country. So there's no question on the availability of the data uh, anywhere you are in our country or in the regions or in the LGUs. Now, in terms of readiness to use the data, um, I would say there has to be some training involved, uh, capacity building. We need to reach out to our LGUs and ultimately maybe the fishermen to teach them how to interpret and make use of these maps. No? So essentially po, maybe one form of information is a map. So the very basic kind of training is to teach them how to read the map, how to interpret it, and how to make use of it. Um, also, it can be further simplified, say, into statistics. So we don't need to give them maps, but just numbers. Say, for example, we tell them that the level or the turbidity level of this lake or of this fish pond has gone up beyond the threshold. So instead of giving them a satellite image, we tell them qualitatively whether it exceeded the acceptable threshold or not. Similarly, say if there's red tide or monitoring red tide possibilities, we can give them like a warning whether what is the probability that red tide would occur, translate it say into percentage. So that way, this information can be readily absorbed and used on the ground.
Have you done any pilot study with regards to that? That I mean, the translation for your LGUs.
Um, our group, personally po, not really, no. Our activities are more on the upstream side in the sense that we are developing the technology. So it's still on the research and development side. But as part of it, we actually conducted a number of validation and calibration um, experiments, but it's a very controlled setup wherein we guided our enumerators, how what kind of data they will give us. So it's not in terms of using it operationally. So we haven't gone to that level yet, but that's just our group. And I think there are some other groups, no, other than us, who have maybe done some pilot studies already.
Are you familiar with any government assistance for this purpose? Government
Ah,
assistance po for this purpose. Are you familiar
yes
with
po.
any?
Well, so far po, our interactions are somehow confined with DOST, no, as our primary funding agency. So as you would expect, it's more geared towards R&D. But DOST also has the thrust to actually apply this technology, no, for operational use. So aside from DOST, before we are engaging with them, no, so there are prospects of future collaboration with BIFAR under the Department of Agriculture, and we think that this could be one viable route in order for this technology to reach our general public. And then the other agency is the Philippine Space Agency. Although it was recently established just last year, part of its mandate is to make this data more available to end users. So at least I can name three groups which I think would be at the core of adapting or translating this technology for our use.
Okay. Regarding your satellite data for fishing activity, do you still conduct ground truthing? For example, data shows fishing activity in certain areas, but how do you identify, classify the boats as to flagship and tonnage? And how will this be able to combat IUU and manage fishing pressure?
All right. So first, I'll answer the question on ground truthing. Um, so actually, it's an important step for using satellite technology, especially if we are dealing, say, for example, water quality. Getting water quality products from the satellite, it's almost imperative that certain degree of ground truthing is done to assess the accuracy and the reliability of the estimates that we derive from satellite data. This is actually also quite tedious, but the thing is, we don't need to do the ground measurements all the time. With a limited and sufficient ground truthing activity, we can establish relationship between the satellite and the observed um, parameters and use this relationship later on to translate satellite data into these water quality parameters without the need for further ground truthing. Now, as to the question of determining the types of vessel and what country it belongs to, um, so this is where combination of satellite data comes into play. So normally, we can make use of AIS data, which already contains those kinds of information, provided that the vessel is equipped with these transponders. On the other hand, I also realized that small vessels actually doesn't have this AIS. No? So that is why we usually find boats, but these are not transmitting AIS signal. This is where high resolution data can help. So with high resolution data, usually the resolution is between 1 meter to 3 meter. We can see very fine details, and even smaller boats can be identified. So that helps sometimes. And actually, if we show this to experts, say our National Coast Watch or Philippine Navy or Coast Guard, they actually have they can interpret it better because they are more familiar with the activities in our seas.
Okay. Dr. Gay, what can be done in this forum so that LGUs will be fully informed with this technology and be of help to fishermen and fishermen associations? It is very difficult to convince LGU with these technologies. That is why what steps can be used in the actual ground for this purpose that will help our fishers?
Okay po. I guess that's part of everyone's goal, no? So to
Yeah, because
ultimately, yes,
concern for the coastal communities and the
yes po,
fishers.
opo. Well, one is communication. I think we shouldn't get tired of reaching out to our LGU. So this forum is an excellent venue. We need to continue doing forums like this. It can be an organized program, such as maybe we can do it regional level first, and then from regions to the LGUs. So I guess the first part is just to increase the awareness. I think it's hard to push technology like overnight. So it takes years. I learned, say, for example, in India, which is now one of the major users of this technology, it actually took them few decades before
Decades.
decades. Yes, it's that long actually before their fishermen use this technology. But now they are like more than 90% of their fishermen are using this technology. So we need to be patient, I guess. Well, initially, I also thought maybe it's difficult or it's impossible for us. But after hearing what they did in other countries, I realized that there's a process. So first is awareness. So we inform them, we let them know what the capabilities are. Um, then on the back end are the developers. So that's our part, the academe, the researchers. I think we still need to do a lot of work in improving these products, the level of accuracy and reliability of these products. So this is where we come in. It should go hand in hand. I would say that the technology is very promising. It has been demonstrated to work in other countries. We have to do a little tweaks here and there to make it more customized for Philippine use. So there's still work done. It's not a turnkey system that is already there and we give it to them. Then, of course, there's the programmatic support. The government should realize that the potential of this technology, and they should also be willing to provide assistance on the development side and also on the utilization side. I think they can give some subsidies to the fishermen for making use of this technology. Um, and this whole process has to be integrated and synchronized for it to work. Um, it's an exciting, to me, no, I see it as an exciting opportunity. And I hope the participants here share the same view. So this is really something where we can all work together.
Have you partnered with any local
So
government unit?
yes po. So part of our research before, no, we worked with the Bataan LGU, and also a group in Pangasinan, Sual, no, to validate some of our maps. Again, it's more of an experimental setup. It's not for operational use. And through our partners in UP Visayas, so actually the group of Dr. Bailon, no, we did this research on suitability mapping for mussel culture. And I believe they partnered with several LGUs for testing this technology.
Okay. Um, this is quite long, Dr. Gay.
It's okay po.
Poor governance, lack of alternative employment, and lack of knowledge and data are some of the factors that lead to the depletion of our resources in developing nations like the Philippines. How do we move forward in managing our resources with these technologies, especially in this time of pandemic when people struggle to survive?
Okay po. It's like a Miss Universe question. And then
Complete with ganun.
ganun na lang po. Okay. I couldn't agree more, no, on the first statement. Um, and I guess during these times, it's a question of prioritization. Uh, I think it's easy to address immediate needs, no, with direct impacts. But we shouldn't forget that this kind of technology prepares us for future um, maybe disaster. So like right now we are maybe we don't feel the urgent need to use this technology, but as you see in the benefits, no, it ranges from productivity, preserving our biodiversity and the likes. So we should not lose sight of these future impacts and work towards it. I think we should not forget. It's easy to say divert all the resources now in response to COVID. I think that's an impulsive reaction. It's understandable. Of course, we need to address immediate need right away. But with foresight, with goals and vision, I think this will guide this should guide our future activities. One of the problem that I see is our desire to see the solutions right away. It's always like that po, no? We see a technology, we want to use it uh, right
Immediate
away,
results.
immediately, and then if we don't see the benefit, we dropped it. Said, okay, it's not working. Um, I guess this is not the case for this. As I mentioned previously, other countries painstakingly um, took some time to adopt this technology. So we should try to do the same, I think. Um, I don't know if if that somehow answers the question. I think it's a very difficult question to answer. Maybe later po, we can go back to that as we go along with the discussion.
I think the concern of many of our participants is the impact of this on our coastal communities, as well as the livelihood of our fishers with
You
all
mean for
these
the
technologies.
pandemic?
Yes, especially during this pandemic.
Mm.
Can satellite images detect the spawning, larval dispersal, and migration of aquatic organisms, as well as benthic organisms?
Mhm. So what satellite can detect are actually, no, there are two sources of information. So one is color. So if there is change in color, like say there's a plankton bloom, which is shown as a change in the water color, then that can be detected by the satellite. So anything that manifests as, say, in color can be translated to the different parameters that I mentioned earlier. Now, the other information is the details. Um, so, of course, we cannot see larvae, no,
Yeah,
from
only
the
the
satellite.
benthic
So,
ones.
yeah, so perhaps um, the detailed part doesn't come into play in that aspect, but maybe the color. And actually, there are three. I forgot. The third one is the environment. So not just the water alone, but also looking at, say, the temperature of the environment, the seasonality, the wind direction, etc. Um, so all of these, no, can be analyzed together with the help of the models. You can see movements, no, you can predict movements of migratory species. And I think one very important uh, information is that satellite data are already available for many years. Like there is a historical archive of data which can be used to establish patterns. And with these patterns, observed patterns, we can then extend it and maybe use it for projections or predictions.
Can this also monitor the degradation of macroplastics into micro and nanoplastics?
So actually, in my last slides, no, I showed. So they mentioned it's actually from a Copernicus market report. They mentioned that satellite can be used in monitoring plastics in the ocean. Again, that's where the details come in. No, this plastic clusters, no, are huge enough to be detected by the satellites. Now, in terms of the degradation, the chemical composition, etc., I don't think the satellite will be able to track that. Um, Unless again it translates to some change
Color.
uh, in the color. Now, but there's one thing, no, that's quite interesting, and I presented it in one of my examples. We are able to detect pH from using satellite data. Now, pH doesn't, it's not seen, no. But what we did was there is a ground data of pH. So that's from LLDA actually. So they have a regular monitoring of Laguna de Bay. So pH is one of the parameters that they monitor. Now, with this ground observation of pH, we relate it with we match it with the satellite data, use machine learning models, and establish the relationship between the two. So from there, actually, we were able to translate the satellite data to pH. As to the physical basis of it, actually, we are still in the process of understanding where does the skill come from, but apparently it works. We are able to generate maps of pH in the process. But it's a combination now of artificial intelligence and the ground truth data together with the satellite data. So it's not just satellite data by itself.
When you do the ground truthing activities, do you consult the fishers or is it still part of your team?
Ah, well, we have to consult the fishermen. Actually, like when we did our field works in Bataan and other places in the country, well, as researchers, no, we don't know much about the area. So usually we start with conducting focus group discussion where the fishermen participates. And then in our actual field work, we are usually accompanied by two two fishermen or local representatives. Um, in terms of say exposure, I would say when we go there, they see what we're doing. Although, yeah, I also realized that it's like what is to them, no, like what is this for us. It's I see the challenge there on how we eventually translate that to information, because we go to the field, we bring a lot of equipment, and they cannot imagine themselves bringing those equipment when they fish. Like we have computers, we have sensors, we bring it with us. So we explain to them, no, this is not how it works. This is the calibration part. So eventually, we'll give you maps or we'll give you information, data or coordinates. So to some extent, we teach them how to use GPS, and that's relatively easy.
Yeah.
We ask them to do some reporting for us, like fish catch reporting. We give them GPS, and then they tell us where they catch this fish. So it's on the way. I would say, yeah.
Okay, Dr. Gay, how is your project correlated or related with the project of UPMSI under Dr. Laura David, relating to the use of satellite imagery to assess ocean situation using colors too? The project included hub monitoring, and collaborated with BIFAR to provide ground truth data.
I interact a lot with Ma'am Lau. Actually, when I first started our research on fish mapping, so it's called Fish Must, that was funded by Picard, I consulted with her, and she helped me provide directions as to what to pursue under this project. So I was also involved in the MSI projects on coral reef, seagrass, and mangrove mapping. It was also led by Dr. Laura David. Um, so I would say that the community, I think, is relatively small. We have to work together to gain the maximum impact, no, from our work, and also learn from each other. Uh, it's not ideal to be repeating what
Yeah.
what others have already started. So the idea is to learn from it and expand it. So yeah, so we interact quite a bit. So and with the Philippine Space Agency, we hope this could be further strengthened, and maybe we don't have to worry about getting the data now, because before, that's one of the challenges. Some groups would need to purchase high resolution data, and it's quite expensive. But with a more programmatic approach, this data can be purchased by one entity, and can be used by several researchers.
Okay. Dr. Gay, you mentioned about Diwata. How accessible is the data from Diwata? How can we access it? And then, how secure po ang mga data para hindi magamit sa illegal means?
Ah, so first question po, how accessible? We have a website, data portal. Unfortunately, I was not able to include it in my presentation earlier. But if you're interested, you can send me an email. I'll give you the link to the website. You can download the data there directly, no? I would say that it's for technical users at this point, because what you'll see there are level 1 data. It's not raw data. It has been processed to a certain extent, but not enough to be. It's not information yet. You'd still see maps in gray colors. So. It requires further processing. But technical users can make use of it. And when I say technical users, usually researchers from the academe can make use of it quite easily. And if you need some assistance on the processing of the data, our group from the Stamina for Space program will be willing to assist you. We have a lineup of webinars actually coming up very soon. That will discuss the different procedures for analyzing and processing this data. Now, as for the second question, how do we safeguard the data so it won't be used by, illegal activities? Since it's in a public website, so actually we don't.
We are nawala. Nawala.
Hello po.
Yeah, sige lang po, Doc Gay.
Yeah, well, yeah, you can see my email now.
Okay,
It's
okay po.
it's
Yung
there.
email of Dr. Gay is there.
Yes. Sige po. Since the data is in a public website, anybody can access it. But actually, there is a registration page. You have to be a registered user before you can download. Registration is free, but some of our team members actually vet the users. So that's I guess one safeguard. So yun po muna siguro for now. But that is something that we have to think about. Yeah, and maybe develop some protocols, no, on how to make it more secure. But right now we are really advertising the use of this data, so we want to make it as publicly available as possible.
Okay, so the question, Dr. Gay, is if the government will adopt the streamlining of all these technologies for fisheries management, what would be how do you picture its implementation and where will you start? And what suggestions will you give the concerned government agency?
Okay. So it's like sharing our dreams now. Opo. So if government will adopt it for streamlining, that is very good. So we're all for that. So how do I envision it? Where do we start? So maybe dun po muna tayo sa how do I envision it. So I envision our fishermen using it, of course. In what way? Say for example, well, maybe in aquaculture it's easier, no? Then open sea fishing. Say for aquaculture, we have fish pond owners, or so maybe this information can be made available to them so they can decide how to manage their facility. First, maybe deciding where they set it up, what are the suitable sites. Of course, it's like a big investment, but suppose they already have it, it's there. And already. So we now come, this technology can now be part of the monitoring tool. No, I showed an example where we look at Laguna de Bay, changes in turbidity, TSS level, chlorophyll, etc. So we can provide this water quality information that fish farmer might need to make their decision. So how would this information be provided to them? Um, it's I would think the LGUs could be one avenue, no, but also I think private uh, private partners or entities um, can eventually come into play. I think that's what happened in India. They have private groups that develop this into services, into products. So usually it's people ba yung private entities, they have ability to commercialize it and translate it really into more easily used information. I think they also have a role to play. Relying on government alone all throughout no, in the process um, might be difficult. So I think the initial investments in terms of the like the satellite development part, the access to the satellite data, this is where government can come in. And then the value added products, I think small private groups can invest in it and make it more available to different users. I think, yeah, they can also have a role. Um, Maybe it's easier, but honestly, I'm not sure if it will work here. But sorry, yeah. Um, That's what I have at the top of my mind po.
Availability and affordability
For
are.
the, opo. Well, yeah, the thing is, if the data is open, so there's not much investment as to the access of the data. So it should be made available at an affordable cost. Of course, it's desirable for it to be free. Um,
Which is
but
doubtful.
Pero po, yun nga po eh, I'm not really that familiar yet with the system, no? If how we can make it, like the government can support it all the way up to the dissemination. Um, but yeah, I guess all parties can play a role. The government, our LGUs, um, our private partners. Um, And actually, I even, hindi ko pa po na-mention yung social aspect, no? Our social workers, actually, they also they will play a big role here in terms of the adoption of the technology. They can bridge and communicate this to our fishermen. They have the skills po to do that. So I think we can also tap them.
After all the work that you have done for with regards to satellite imagery, how will you be able to assess the impact
Hmm.
when it comes to monitoring and evaluation, the impact of these technologies in the fisheries sector, concentrating on the fisheries sector? Paano nyo ma-assess? Anong inyong indicators
Indicators.
of success?
Okay po. Uh, that's a very good question. So it's not straightforward. Well, I guess it comes into there are different means, no? A direct one would be, say, production. The output, like fish catch, um, amount of well, yield or growth in in the, well, production in general. So that's easily measured. If it's a controlled setup, like you have cooperators, like fish pond operators, so you can get this data. Of course, there is the assumption that they would be reported correctly because I guess that's also some of the challenge, no, like underreporting of production or fish catch. So on the assumption that we'll get the correct figures, that would be a direct way to measure the impact. Suppose before they don't use this technology, how much catch did they get by using the technology, how much did it increase or decrease? So that's one way. Say for fishing, no, we can measure the savings in the fuel cost. Suppose they spend more time before to fish. Now, with the use of technology, they can fish more easily. We can factor that in, look at the cost savings. The other one is on, say, quantifying the loss. Say, for example, fish kill. We can quantify how much stocks were destroyed due to a fish kill. And then if we are able to avert it, by using the technology, we were able to advise our operators as to the amount of nutrients that they will apply. If it's and fish kill is averted, then we can compute for that amount as well. Another one would be tourism. So, for example, we had this jellyfish bloom, or suddenly the area is not conducive for swimming. Then we see drop in tourist activities. Then we compare it when we are able to do better coastal management and maybe increase the tourism activity. So we can quantify that impact as well. So other means would be like looking at well, biodiversity in the ocean. If we are able to maybe increase it by protecting spawning areas. With the use of technology, we know where these are. We know which area to protect. And by enforcing some policies, we can take a look if it translates to increase in fish stock or increase in biodiversity in the region that we protected with using this information as a guide. So these are just some of the concrete ways which I can think of that can be used to quantify the impact of this technology.
Dr. Gay, how can women's group participate in the adoption, implementation of this technology, and what are their roles and functions in the achievement of these goals?
Uh, I would say well, I have not interacted with women in the industry yet, no, but I can cite an example for farming po, no. This is agriculture. So when we go to the field, we do our key informant interviews. There is a high chance that we'll be talking to the women in the community, like the wives of the farmers. And we observe that it's like, it's a pattern that we see, no? And the reason is that usually the head of the family is out on the field, they're doing their farming, while the mother, the wife, they stay behind. They're the ones we can talk to. So that's for farming. But I think it could be the same also for our fisher folks. Um, when we go to the houses, you'll probably see women there, no? So in terms of communicating, I think they are the ones that are more accessible, and that, of course, women's group would know better how to set up programs that will engage women in the community to participate in the discussion. So I think they could help in this sense. We haven't tried it. I haven't seen it working yet, but I can imagine the success rate would be higher if we get the help of the women's group.
Okay, so maybe it's something to consider, Dr. Gay, when you do your ground truthing. What are the
Yes po.
perspectives of the men folk versus that of the women folk? Okay.
Yes po. Opo. Okay, yeah.
Have you targeted big aquaculture farms to partner with you for the demonstration of all of the value of
Mm.
your technology? The bigger aqua farms.
Um, sa aquaculture po, actually, my experience so far is with a group of Dr. Bailon through the, yeah, opo, yung muscle uh, suitability mapping. I'm not so sure if they have already engaged with big aquaculture farms, because right now it's in the deployment stage, I believe. But my personal experience is more on the fishing side, um, where when we developed these fish maps, there were actually interest from big fishing groups like tuna companies to test this technology. Uh, but one of the, well, it did not materialize. No, they were very interested about it. But I think one of the challenge is at that point, they are not ready yet to share the, well, as part of the validation po kasi, we would want to get information or ground truth information from them, no, on the use of the data. So for example, we give them a map to show where the fish are. Then they will tell us if they were able to get fish there. So the location essentially of their fish catch has to be disclosed. And that was where, well, it's still under discussion. Like, will they be willing to provide those information? Some of them regard it as trade secrets. So that's one. No? That's for open sea fishing. So it's a bit more challenging, I guess, to test it, unless there are willing partners who will give you the information, because we need to check whether the map we gave them really directed them to a school of fish. So they have to give that information. But what we did in lieu of that is to use other technology like nightlight data, uh, where instead of actually getting direct data from the fishermen, we use the nightlight as an indicator of their fishing activity. So with that, we were able to validate areas that are productive and where they actually fish. So, but for aquaculture, we are looking forward really to test this technology. Um, um, yeah, so I hope we can continue through, maybe through this forum. We can find interest partners to test this technology.
Okay, thank you, Dr. J. I think this will be our last question and comment at the same time. This technology is really helpful and can be easily applied by BIFAR. I hope you can collaborate strongly with BIFAR because for now, this is what they are strengthening for vessel monitoring as well as to combat IUU within our archipelagic waters.
In the works po, like as we speak, no, our team is following up on our meetings with BIFAR. So while we are in pandemic, we have been talking to them, of course, virtually. And there is a strong interest from BIFAR on the use of this technology. So yes po, we look forward to really working with them and integrating this technology in their system. And so far, they are receptive. So we are very excited about it.
Okay, so with that, we want to thank Dr. Gay Jane Perez for our for her presentation this morning. Dr. Gay, any last words, parting words for our young researchers and old researchers also?
Yes po. This has been, I guess, a very, to me, no, insightful discussion. I didn't know much really about the profile of the audience, so I'm not so sure what areas to focus on. But based on the questions, so I had a better gauge of the interest of our participants. And I'm glad to know that there are it looks like there are, or you are open to the potential of using this technology. To our researchers, young and not so young, but young at heart, I want to encourage you to be part of this field. I would say it's for our country, it is still emerging in the sense that there are more work to do. So I hope this talk got you interested. We need you to bring this technology ultimately to the level where our fishermen will be able to use it. As to the final form of how it's going to be distributed, um, uh, we can only speculate at this moment. But as researchers, we can focus on improving the accuracy, the reliability, and making this technology accessible and available to our users.
Maraming salamat po, Dr. Gay. And with that, we bring our presentation to a close. But thank you very much, Dr. Gay.
Thank you din po.
And we look for more collaborative projects between your group and the other SUCs from the APPP.
Yes po, I look forward to that as well. This has been an enjoyable forum for me. So thank you po for inviting me.
Thank you rin po. We now go to the next part of our forum, our webinar, the presentation of our past most outstanding fisheries professionals, just so you will get to know them. Our first Our first scientist is Dr. Benjamin J. Gonzalez. Doc Ben, as we fondly call him, has a 39-year fisheries job experience as an academician, practitioner, and researcher. Dr. Gonzalez is a PhD in fish ecology and population genetics from the United Graduate School of Ehime University, Ehime, Japan. Dr. Gonzalez is also an integrated fisheries and coastal resource management specialist, a biodiversity management specialist, and a full-fledged professor. He is currently the Vice President for Research and Development Extension of the Western Philippine University and was the Director of the Southern Tagalog Islands Research and Development Consortium. He spearheaded the accreditation of the BS Fish program of WPU to become a center of excellence in fisheries education in the region and in the country. He spearheaded the ISO accreditation of the RDE department of WPU. Dr. Gonzalez has proposed the creation of the BS Aquatic Bio program of WPU, which is currently a recognized research institution in its field. He has authored peer-reviewed publications on biology, ecology, assessment and evaluation, and management of coastal and marine resources and ecosystems, book chapters, books, and manuals, including 9 books and booklets. He has presented papers in national and international symposia and has served as keynote speakers to conferences here and abroad. Several of the results of Dr. Gonzalez's studies are used as basis for policy and decision making. Cited in the Google Scholar with 7H index and 173 citations by other scientific papers, and has 16 Best Paper Award. Dr. Gonzalez is our Outstanding Fisheries Professional for 2017. Next. Our next outstanding fisheries professional is Dr. Emilia Tobias Quinicho. She obtained her BS Fisheries and MS Fisheries from the University of the Philippines and her PhD in Fisheries Science from the Hokkaido University in Japan. Currently, she is the Secretary of the Integrated Services for the Development of Aquaculture and Fisheries, or ISDA, Inc., a corporation composed mostly of former scientists from the Aquaculture Department of the SIFDE, with expertise in aquaculture and fisheries. Dr. Canicho retired as a senior scientist from SIFTEC AQD in 2018. She is known for her expertise on mangrove, or mud crab, in the Philippines and other countries, as evidenced by the invitations she has been receiving as resource speaker in conferences, workshops, and other meetings, as technical lead person in training courses, research proposals, and manuscript review, and as thesis advisor, reviewer, critic of graduate students locally and internationally. She is also an active member of the Technical Working Committee in the development of the Philippine National Standard for Fish and Fishery Products. She also assists in the drafting of ordinances for the management and conservation of mangrove crops. She was the overall program coordinator of the National Mud Crab Science and Technology Program, funded by the PICA-RDOST. She has published 72 papers in refereed scientific journals, proceedings, and manuals as author and co-author. She has been a guest editor of Aquaculture and editor of Proceedings and other manuals. She is a recipient of several awards, and some of her major awards are the Dr. Elvira O. Tan Memorial Award of the DOST for the domestication of mud crab, the Giant Steps Award as promoter of mud crab aquaculture in the Philippines. Ma'am Babes, as we fondly call her, is the most outstanding professional for fisheries in 2018. Our last outstanding fisheries professional is Dr. Serapion Tanduyan. Dr. Tanduyan is a university professor and designated campus director of the Cebu Technological University in San Francisco, uh, Cebu. He was the former director and founder of the Center of Limnological, Aquatic Biodiversity, and Mariculture Studies of CTU. Dr. Tanduyan has conducted researches on limnology, aquatic biodiversity fisheries, social sciences, educational, tourism, and technological researches and other related fields. He has served as a consultant for researches funded by both local and international agencies. He has served as a resource person, moderator, session chair, as well as paper and poster presenter in local, regional, and international fora and symposium. Likewise, he has won scientific paper and poster awards in national research conferences. He has published papers in refereed journals and proceedings in local, national, and international journals. Dr. Tanduyan has published two assessment guides of sea cucumbers for the island municipalities of Cebu. In February 2020, he published a manual on off-bottom culture of Caulerpa in plastic cages. In 2016, he was awarded as one of the outstanding faculty of Cebu Technological University. Dr. Serapion Tanduyan is the most outstanding professional for 2019. Okay, so we have introduced to you our three outstanding professionals in fisheries. And now we will go to the just some announcements before we have our closing. Again, you have the instructions for membership. And we also saw this, the oath taking, online oath taking of the new fisheries technologies, which is going to be on November 16, 2020, Monday at 1:30 p.m. So please just check the website of PRC for any other requirements. So with that, we now bring to a close our program, but first we will have the closing remarks from Dr. Harold M. Monteclaro.
Okay. Thank you, Ma'am Sins. Magandang umaga po. Good morning po sa lahat. Well, as you all know, each year the APPP organizes seminars that allows us to meet with each other and then discuss fisheries-related issues together. But because of the pandemic, we are forced to adopt measures such as, instead of actual face-to-face meetings and seminars, we sit in front of our laptops or gadgets and to listen to our resource persons and also to learn from their presentation. This had been a tall order for us in APPP, especially this is the first time that we are doing webinars. But I'm extremely happy to note that we have successfully conducted 3 webinars in a period of 3 weeks. I therefore extend my sincerest gratitude to our resource persons, to Dr. Gay Perez, Dr. Rowena Iguia, and Dr. Lourdes Cruz, who shared with us their expertise. And I also hope that even if this is a webinar, it has still been a venue for everybody, to formulate networks with our resource persons. I'm sure Dr. Gay, Doc Queng, and Doc Luli would be delighted to collaborate with you, with matters related to research, for mga kasama natin who are doing research, or if we are implementing projects or activities, if we are in the local government or with NGAs, or matters related to our teaching, if we are into members of the SUCS. I'm also grateful to the members of the APPP board and also Dean Mimi Yap of the College of Fisheries and Ocean Sciences of UPV, as well as our support staff and volunteers for their dedication and hard work to get everything going. Siyempre, I also wish to extend my thanks to all members of APP who have joined us in our webinars from day one. We know that you are also excited to see each other in person. Hopefully, the pandemic will be ending soon so that next year we can do our seminars na, magkatabi-tabi tayo, magkausap tayo. And also for us to do a business meeting so we can attend to issues related to our professional organization. But until then,
I pray that you continue to keep safe from the pandemic, while at the same time attend to our functions and mandates, whether we're members of SUCS, private sector, LGU, NGAs, NGOs, or in any other capacity as a fisheries professional. So marami pong salamat uli, and I'd like to declare the close of the 2020 APPP webinar series. Marami pong salamat.
Thank you very much, Sir Harold. We would also like to remind all our APP members to please send in your evaluation forms before 12 o'clock tomorrow noon. So with that, we bring to a close this webinar series, and maraming salamat po. And stay safe, everybody.